What we'll do today is just have a look at another problem of influence lines, just by way of a further example for you, be it had. So, take a look at this structure here, which looks a little bit like a cable stayed bridge. It is a simplified version of one, in which we'll assume, for the purpose of this exercise, that a pin joint at each end of the stairs, and also a pin joint up there at the top. We've got 6 spans in here. They're all the same 30 metres. And the height of the tower of the deck is 60 metres. This has been taken from an exam paper quite a long time ago now, but if you look at some of the more recent papers with structures 4, it's nothing quite the same, but there are similar sorts of things in there. Let's start off and see if we get the influence line for the moment B. The tower of this structure has a fixed base at A, continuous up to C, and this section of deck is pinned to the tower, and this section of the deck is pinned here to the tower as well. So the deck is discontinuous at the tower and just pinned onto it. So you just like to have a think about that for a minute and see if you can get the influence line for the bending moment at B. So that is the bending moment in the tower here of the deck. You could start to do lots of calculations. That would probably take quite a long time. It's much better to use the virtual work approach. And in the virtual work approach, you imagine you break the structure at B as far as the force quantity we're looking at is concerned. So, effectively what you want to do is say, we're going to break it for a bending moment at that point, keep everything else intact, so you've got to put a pin in there, and then apply moments like that to the structure. So we've got a pin crept into the tower here, and you imagine getting over that bit and trying to turn it that way, and this bit and turn it the other way. And the shape of the deck, that will be the influence line. We'll have to do some sums to find out some values, but at least you get the shape with that. Remember, as far as a structure like this is statically determined, the influence line will be made up of straight lines. There'll be no curves or bends. You only get those where you've got continuity. So it's going to be a series of straight lines across there. So it's rigid body movements. And rigid bodies can be single members, or anything that's made up of a triangle also can't change in shape. So you can think of that as being, if you want this triangle in there, for instance, it's a solid block of material. So when you think of the movements of the structure, you can think of it in those terms like that. So I would say you want to think of trying to draw the shape with all the hangers and stays moving around. Just think of what the shape of the deck will be. Probably we should be able to come up with that in a couple of minutes, and then you can go back and look at that and think, well, if we put a unit load at the place where you look at it at the moment, would I really expect that to be the case? Then what we have to do is, once we've got the shape, find some values. Just have got anybody stuck or wants to ask? I'll get started. These questions are quite straightforward, as long as you can visualise how structures move.
Continuous support.
It isn't hard. You still walk it and go down.
No, it's much better.
Take a bottle, yeah?
That's your fault, dickhead.
Continuous structure, my bollocks. Continuous.
Place it further down, innit?
No, but you won't be able to see it properly. You won't be able to see the whole board.
You can't.
Fine. You.
Don't bitch about with me.
Oh, well, it's in the tower of the... B is part of the tower. So B is within the tower.
What do you think, John?
What do I think?
Must have changed things line.
You're doing it to try to put a tower.
Because look, how, I don't know. Because it's a pin, the end has to be 0, right? The moment has to be 0. At that end, the moment also has to be 0.
It can't be 0 at the fixed end. Why is it 0 at the fixed end?
Where?
At the bottom. Mine it won't be 0 at the fixed end.
Yeah, you're right. But you're breaking it there. It's a...
That's the way we're applying the moments.
Oh, Onchi. There you go. There you go.
But you got a shape, yeah?
Yes.
Go on.
It might be wrong. It is wrong. I don't know.
Well, no, it's the deck we're looking at.
Yeah,
Oh.
first house.
So what we want to know is what shape that will adopt,
Oh, okay. Not the tower.
not the tower, because
Right.
the unit load is going to cross there.
Ah, yeah.
So it's the
Will it-
shape.
will
The
it
shape
even
of the
change?
deck you're looking for.
Will it even change if the bending moment going this way? Probably won't change at all.
It will, because at this end you'll have, it's a pin, so it'll go there, so it'll be like that.
Yeah, but it can't transfer the bending moment. Can it? It's a pin.
But then he's talking about unit load. Where's he applying unit load? At B, isn't it?
At
If
B,
you're gonna,
yeah.
so if you're gonna apply unit load at B,
Yeah.
the further away you go, the further the moment will be. Isn't it? It's confusing. It's like, yeah, I know what you mean. What's your value? What's your value, dickhead? Dickhead.
Easy.
Fuck off.
Oh, you just got had up, man.
Nah. He didn't explain properly.
He's going to go in the exam like, what? What's your problem? Huh? Give me full marks in it.
I ripped you, dude.
Give me full marks in it. Really? Give me full marks. You go up to his office. What kind of paper was that? Turn your Jews and you get here. Turn your Jews will see you twatting bell, and then he'll start running. He'll chase him. Get over here, G. He'll just scorpion thing.
Alright, let's try and sit now. I can't believe that happened to me this morning.
Where the hell did that shot come from?
You should have played the game.
What? Obviously, I clicked on. I was already in gear anyway. I was in deep flow. I was like, I parked up, went upstairs, bastard, nothing there. So I was like, fuck, he's lying.
At first.
What you're trying to do, you might imagine my ruler as the tower.
Why is he wasting our time, man? Just do it, innit?
Don't like the mention of the moment. Then what you're trying to do to the tower is that. So if you do that to the tower, what happens to the shape of the deck? The tower goes that way. What happens to all this lot here?
It's the opposite round. But then you're looking at the moment.
Remember, as being rigid
Have you got a rubber?
Yeah.
surfaces,
It's in my hand.
stable in themselves, they won't change in shape. So what happens to that line D to E when you do that rotation there? So you just put a pencil or a ruler sort of on the page and do that. Imagine all these bits connected to it. Then what happens? What happens to the top?
Oh, is he not going to be like this? Is it? What you're doing is you're saying basically the deflection is going to be zero at those ends.
22 июня уже будут доступны все оценки degree classification.